if you've ever paid attention to the price of things at the store, you've noticed they go up and down. And to some extent, that depends on what season it is, right? Swimsuits are not going to be as expensive in September as they are in March, because retailers know in March they're about to sell a whole bunch of swimsuits, so they don't need to mark them cheap. But in September, they're just trying to unload all the swimsuits because they don't want to hold on to them for another year, right? That costs them money. They might not be a popular style anymore, who knows? So prices will fluctuate up and down, and that's even aside from the general upward trend in prices from inflation. So what I want to do in this problem is look at some product, right? And the retailer increased the original price of that product by 30%. Who knows why? Maybe it's inflation, maybe it's just that it's a particular season where that product is more popular. So they increased the price of that product by 30%. And then later, maybe it's the end of the season, maybe they're just trying to unload, they decrease the price by 15%. So what is the final price as a percentage of the original price? Here's how we walk through that. First, let's say the original price is X. Okay, so X equals the original price. I have no idea what that is, and I probably will not figure it out in this problem. But I can say that 30% of an increase, 30% increase looks like this. It's plus 30%. So in other words, you can think of it like this: X plus 0.30 times X, right? There's my 30% increase right there. That's the increased price. And a lot of people don't even do this step. They just skip right to it and say, well, 30% increase is 1.30. Here's how they make that jump. They say it's X plus 30% of X, and that's 1 plus 0.3. That makes 1.3. So here's the increased price. And then, get a load of this. Now we're decreasing the price later on by 15%. So what we do here now is we say, you might think multiply it by 0.15. That's not actually what's going on. That would be timesing it by 15%. We're decreasing it by 15%, which means we're taking this thing and we're subtracting 15% from that. Okay, so in other words, it's going to be 1 minus 0.15 times 1.30x. Now, if that 1 minus 0.15 is confusing to you, think about it this way. If I sold you something for $1 and then offered you a 15% discount the next time you bought it, it would be 85 cents, right? It wouldn't be 15 cents. The discount would mean it's only 85 cents. That's 1 minus 0.15. So now we just go ahead and calculate what this is. Okay, so this is going to be 0.85 times 1.30 times x. Okay. Definitely a job for the calculator. All right, so that is 1.105x. And as a percentage increase, what is that? That is a 10.5% increase. See what I did with the digits there? These first two digits are the percentage increase, right? That's a 10.5% increase right there. So here we have our answer. It's about an 11% increase, or 111%, okay, right? 100% would be the original price, plus 10.5% equals 110.5% increase, of the original price. This is obviously rounded, right? 111%. But I want to point out what the answer is not. Okay, let me put the bad idea over here. This is what the answer is not. This is how you do not do percentage style equations. You do not simply say minus 30%. I'm sorry. You don't say plus 30% and then minus 15% and get equals 15% extra, right? That would not be the way you do this, right? We don't have 115% as an option. We only have 111% as the top. So watch out for this. And I would say when you're doing these sorts of percentage problems, always just set it up as little equations and play around with them that way. And if you want, substitute dollars. Like use $10 as the original price and work through it with actual numbers if you don't like the x's.